You doing good? All right, let's do this then. Now, by the way, guys, we really have 15 minutes more breaks left. I would just as soon skip our breaks, go to the end, and
Leave early.
well, no, but I try never to leave early, but let's put in our party hat.
Party hat.
You guys sound good? Should we go to the end? So let me give you a couple more problems here, okay? So, in this case, first of all, who wants this for notes? You guys doing okay on this? All right, everybody got their notes taken? All right, so let's do this then. Here are some scenarios, okay? Now, let's deal with the first one. You're considering buying a machine, okay? So you can, should I buy this machine? Okay? So what you want to do is now you're considering buying a machine. Now, you're going to use it for 5 years. Okay? There's no salvage value. And of course, the salvage value, you can work that just fine too, but that's a step that's not needed. It will create $5,000 net income per year. Okay? Now, the interest rate is 10%. How much paid for it? Okay, so let's take a look at this. So, is this going to be a single sum or an annuity? It'll be an annuity, right? Because you buy the machine and it will increase your net income $5,000 per year for every year. So that's an annuity, right? Are you looking for the present value or the future value? The present value. What's the present value of all this future annuity? If you pay that for the machine, you'll break even. If you pay less, you're ahead. If you pay more, you lost money. So how much, where's your break, you want to call it a break even? Maybe a better way of wording it. Where do you break even on this thing? All right, so, did you guys get 18,954? So basically what it is you use table 3, because what you're looking for is the present value of a future annuity, and you'll have an N of 5, because there's 5 compounding periods, and you'll have an I of 10, because it's 10% per compounding period. So that gives you a factor of 3.7908. Multiply that times the annuity. That means if you pay $18,954 for that machine, and it gives you $5,000 every year for 5 years, and then you throw it away, you'll have broken even. Now, don't forget, whenever you do something like this, you're crunching numbers here, but there's more to numbers that go into a decision. If it turns out that you would have had to pay more than this, you would have lost money, but you may have done it because it pulls customers in who may buy other things. Okay, but when you make a decision like that, do it with your eyes open. So, all you're doing here is crunching numbers, but numbers are only one part of a decision. Because you may choose to pay more than this, that means you lose money on it. But it may be worth your while. Is everybody okay with that? All right, any questions? Let's do a second one. So in the second one, again, you're considering buying a machine. Okay, but now you're going to use it for 4 years. Again, it has no salvage value just because it makes it easier to work with. 12% interest. That's what, okay. And it saves you $10,000 per year. Okay? How much should you pay for it? And again, are we looking for a single amount or an annuity? It's an annuity because it saves you $10,000 per year. You're looking for a future value or present value? You're looking for a present value. Okay? In this case, you're going to use table 3 because you're looking for the present value of a future annuity. You'll have an N of 4 because there's 4 compounding periods. You have an I of 12% because that's what the bank is going to charge you interest. Okay? So that means the factor is 3.0373. Multiply that times the annuity. That makes the present value of that annuity worth $30,373. So, if you pay this amount for it, it will equal your savings. If you pay less than that, your savings will be greater. If you pay more than that, your savings will be less. Should you buy it as and this is just part of your planning. Okay. All right, you guys doing good? So, you're doing good? Any questions of any kind? All right, let me go ahead. So let's just kind of sum up then. So the point of the matter is, what you want to do is, what happens, actually, I'm going to turn off this camera since I think we have everything here. Or actually, there's no point in turning up. Let me just leave it on. So let's go ahead and just sum up. And I think when we sum up, it moves into the long-term memory. So what we're talking about here is compound interest. That's where you pay interest on interest. And it means that money grows. So that $1 today is worth more than $1 in the future because this dollar grows to a greater amount, right? So in this example here, it's 10% interest, compounding annually. So if you put $1 in today, it will gain 10 cents of interest over the year. Add back to your principal, so it grew to $1.10. You leave this $1.10 in there. Now it has 10% interest, so now it pays 11 cents. Add back the $1.10. Now it's grown to $1.21. So the present value. So if you want $1.21 in the future, deposit $1 today at 10%. So the $1.21 is the future value. The $1 is the present value. In the main, the secret to making this whole chapter work is just decide what table to use. So sometimes you have a single amount, sometimes you have an annuity. Annuity is the same dollar amount at equal time intervals. If you have a single amount and you're looking for a present value, use table 1. If you have a single amount and you're looking for a future value, use table 2. If you have an annuity and you're looking for the present value of that annuity, it's table 3. If you have an annuity and you're looking for the future value, it's table 4. And much of what you want to do here is just choose the correct table, and after that, it's just plug and chug. Plug and chug. Sounds good? The other topic that we brought up is the fact that suppose you have 8% interest that's compounded quarterly, and let's say it's 1 year, or let's say it's 2 years. What that means is, you divide this by, it's compounded quarterly, so you divide it by 4. That means it's 2% per compounding period. And let's say you're going to have it for 2 years. That means there'll be 8 compounding periods. So in this example, you'd have an N of 8, and you'd have an I of 2%. So you figure out the number of compounding periods, right? It's 2 years, 4 per period. 2 times 4 is 8. And it'll be 2% per compounding period. Sound good? That's the other topic. All right. And where you'd use this is if you buy a machine that will make you money, you figure the present value of all that future money. If you buy a machine that will save you money, you figure the present value of all that future savings. Or if you win the lottery and they give you these choices, you'll know the right choice to make. And of course there's don't forget, now these are just the quantitative numbers, so there's also qualitative decisions. So incidentally, this 82-year-old woman won the lottery, and they gave her the choices, and she chose to take the lump sum immediately. Okay, which makes sense, right? Yeah, none of this annuity, well, unless it would go on to the grandkids or something. All right, you guys doing good? Trust fund, sure.
So I guess what I'm thinking of is like if you did that thing, on the one problem we did, where the best choice was to take 10,000 after 5 years. So that'd be an example of a time where it might make sense to take out a loan if you wanted that money then, and then you would definitely be able to pay it back.
Yeah, it can do it. No, and by the way, to show you how something like that works, incidentally, is suppose you have a CD and you want your money now. You've had the CD for a while, so there's not a lot of time left on it. And suppose there's a withdrawal penalty. Well, what you can consider doing is rather than withdrawing the CD, take the heavy penalty, you might use the CD as collateral for a loan. And the interest on the loan would be less than the penalty on the CD.
Yeah. And
so, in answer to your question, you're right in the money, and that's how it would work. Okay? Sound good?
Yeah.
All right. Well, you guys, we've gone over, so we'll call this good. We'll see you on Tuesday. Can I walk past you guys and I'll turn this thing off?